Hello, and welcome to another live stream. So, quite looking forward to this one because it's going to be a chance to work on Incus itself instead of other kind of connected things. And yeah, recently I've been spending a good amount of time working on things related to networking, often specifically. And I'm slowly building up a list of kind of rough edges and things that need to be improved so that it's just easier to interact with and so that it unblocks some of the upcoming work I've got. So just to give like a quick overview of where we stand right now, obviously Incus 0.3 has been released. It's seeing a fair amount of adoption. The kind of headline feature of Incus 0.3 was support for OpenFGA. Since that release, I've started using it on pretty much all of my systems and found a number of issues with the initial implementation of OpenFGA by the LexT team. So I've been spending quite a bit of time over the past few days fixing all of that. I think I've got a pretty good handle on it now. It's really behaving for me. So gonna like 0.4 is gonna have a very solid OpenFGA support. 0.3, if you're using it from my packages, I've cherry picked the most important fixes. If you're using it from another distro that didn't include those fixes, then you might want to wait until 0.4. As you can see, a lot of changes related to authentication, authorization, and OpenFGA over the past few days. All right. The other thing I've been doing is I've been populating the list of issues a fair bit. So you've got a lot now of small bugs, small features that people can take and kind of use as a first step into contributing to Incus. So there's quite a few things there. If you want to get started on any of it, just comment in there. I can assign it to you, and then I'll give you some pointers on kind of where to get started. For today, the issue we're looking at is this one. No, wrong one. How do I go back? There. It's this one. So effectively, when you use Oven, there are multiple ways you can connect to the Oven database. If you're running just a single system, you're going to be using the Unix socket. So that's very simple. There's no network involved or anything. You just talk to the local database of a Unix socket and you're done. If you're using kind of more test environments, usually you're not going to really bother with security stuff. So you're going to be using just plain TCP, which just requires you to know the addresses of all servers, which gets you the connection string for Oven. You put that as your northbound database connection string in the Incus config, and you're done. Now, if you're running into a more serious environment, you're probably going to want some amount of security around that. And Oven does support doing TLS. So at that point, not only are the endpoints themselves now effectively over TLS, but it's also using client certificates to confirm that the client talking to it is actually allowed to interact with it. And Incus does have support for that, but it's quite hard-coded. It effectively expects specific keys to be available within a /etc/oven directory. And if those keys are found, then it will use them when talking to the database. That works, and it was working pretty well with the LexD snap, because in the snap environment, the snap controls all of its file system effectively. So we could guarantee that /etc/oven effectively belonged to us, and we could put whatever we wanted in there. Now with Incus running on more traditional distro packaging, we don't really own /etc/oven, and we don't want to assume any specific layout or file names or anything in there. So the idea I came up with is simply let's add another config key. So if we go look at the current documentation for Incus, and we go on the server config keys, which should be here. Okay, there are a number of them, and there should be, where is it? It's under MISC, I think, right now. Here it is. So here we've got network.oven.integration bridge. That one doesn't really matter for us. But then we've got the northbound connection. So that's the one that defines where, like, how to contact Oven. That's fine. what I want to do now is add more config keys in there effectively, so that the CA used to validate the server, as well as the client certificate and client key, can be provided directly through those config keys. So that makes it possible for someone who just has access to the Incus API to then configure the Northbound connection string to connect to the remote oven API, as well as provide the keys needed to actually interact with that. Now, as far as I know, the command line tool for oven doesn't actually let us easily pass those keys through the command line. It's also not super clean to do that, because then all the private keys and stuff show up in the PS output, which can be seen by any user on the system. So that's not good. As the config key can be changed at just about any time, I don't really want to maintain persistent files on disk. So my current thought, and what we'll try to do today, is to effectively pass in potentially pipes that might work. So using effectively a pipe FD for that. If not, using like a temp file that gets deleted immediately afterwards. But I'd rather not even involve the file system if I can help it. So that's kind of the idea, is to effectively pretend that we have files. Those files will be just numbered file descriptors, and have Oven read from those to read the keys. I'm assuming that Oven only reads them once, so if we use a pipe and we just pre-fill the pipe with the keys, then things should work, but we'll find out soon enough. So that's pretty much the idea there. That will unblock some other things, like I'm currently looking at interacting with Oven interconnection, for example, which is a way to connect two completely standalone Incus deployments with their own Oven deployments, connecting them together so specific networks can route to other networks on the other Oven. To do that, you have more databases to deal with, more keys to deal with. So that's why putting this infrastructure in place is a good first step, because I'm likely to have more keys to deal with soon. All right, so first thing first, I've been setting up a dev environment. So what I have here is I've got 3 systems. Let me just increase the font size a bit. There we go, that should be better. 3 systems, they do have Incus, but I've not actually initialized anything yet. So Incus is installed. And if we check, that should be 03. Yep. Okay. So I've got Incus on all of them. We'll just need to cluster that together still. There we go. And for Oven, I went with micro Oven, simply because it's a convenient way to get Oven with TLS support. So I believe I've set up the cluster already. You can just go and check status. Yeah, okay, so it is running with the 3 machines, and I've not used micro-oven in a while, ever since I left Canonical, but I believe there should be a config key in here somewhere. Yeah, there we go. So there's oven.env, which gets us the connection string, so we can see that it uses SSL, and that means it's gonna need to use certificates. Now, getting those certificates, let's see how that works. I suspect they must be on disk somewhere, and they are. Okay, so there's a PKI here, PKI directory, which includes kind of what we need. So there is the CA certificate, and then a client cert and client private key. So those are the ones we're gonna want to use. The rest are used by the daemons themselves. We're gonna be ignoring those. So the first thing I'm gonna do is actually cluster those systems together, and once they are, then we'll connect them to Oven kind of the old way, where I'm gonna move those files into the file system locations that I expected. Then I'm gonna go ahead and create network instances, make sure that Oven does work properly. And that's gonna give us kind of a starting point where I can then go and work on Incus itself to add support for those new config keys, and let us easily confirm that everything still works once we remove the files from disk. So that's the idea. Also, just a bit of warning, I do have Amazon coming to pick up a return at some point, so there's a very good chance I'm gonna have to disappear for a couple of minutes at some point during the stream. Yeah, I can't really get that timing right ever. Anyways. Alright, so how do we do that? first thing first, we're going to be clustering that stuff together. So let's just go ahead and create a new cluster. Do you want to create a new cluster? Yeah. Don't care about storage, really. Don't care about any of the other stuff. I think we can just go ahead like that. And then do admin init on the other two. Okay. And to cluster them, we just need to add them. So that's going to be oven02, oven03. So that gives us the join tokens for those. For joining, copy, paste this stuff in. Yes. Well done. Okay. And then 03, same deal. Joining and token, and yep, go ahead. Okay. So that's done. We now have a working cluster, so that's all good. And the next step now is to connect things into Oven. So what you usually want to do is actually start with a connection string to the northbound database. That's the one we actually care about. So we want to do, I might need the doc for the config key. Let me find that real quick. There we go. Network oven northbound. So this config needs to point to this thing. Okay, so that's fine. Next, we need to create an uplink network. So what I've done is each of those systems has a secondary network card that we can use as the uplink. So we just need to create a network. I usually call it uplink all caps to make that easier. The type for that network needs to be, in this case, physical. I believe is it parent? I think it's parent. So we need to precede that on all of the systems, which means 1, 2, 3. Okay. And then for the global config, there are a few config keys we need to put in place. The first thing I need to figure out is what's the subnet on that network. It's an Incus network as well, so I just need to do that. Okay, let me just find the config keys real quick for that stuff. So oven network config there. Okay. This suggests that network is actually, oh, that's for other network type, never mind. That's what I want. I want physical, external networks, physical, this guy. Okay, so we did do the parent key has been set, which is good. The MTU is going to be all kind of whack because I didn't bother to do jumbo frames to avoid the MTU lowering. It doesn't matter because the good point is to just test the oven interaction. I don't need to carry production traffic on that. So having a lower MTU than normal is perfectly fine. Just like I'm not going to care about IPv6 in this case, just to make my life slightly easier. So we're just going to do IPv4. The gateway for IPv4 on that subnet is 45.1. So put that. The oven range is what range of IP addresses can be used for oven. In theory, all of it, we're just going to tell it to use from 100 to 254. There we go. And I don't think I need anything else. Was it complaining? Oh, it's complaining about it not being a subnet, sure. And it's partially created. Right. One day I'm gonna try and make that less annoying. So I'm just creating the node specific stuff again, creating the network. Okay, so now we do have an uplink network that's defined that can be used by Oven. At this point, we can try it, but I suspect that if I try to actually create another network, it's gonna fail quite miserably because we don't have the config key, well, we don't have the files in place to do SSL. So if I try to do that, there we go, it just failed. Actually, it also fails because that's gonna be slightly frustrating. Let's see. So the issue here is that I'm using micro oven that comes with its daemons and databases and all that stuff. Self-contained, and Incus is not part of that environment, so that might be a slight issue. Let's see. So I'm gonna just install effectively the tools and all that stuff directly on. I don't know if I can install just the tools. That would be nice, but I don't think that's possible. Yeah, it comes with the vSwitch package. Okay. Right, so we need to install that. Also gonna need the oven tools, so nbctl, for example. So that's in oven command. Okay. Let's install those two packages and see if things behave. The concern here being that Open vSwitch is, the daemon is running from inside of the Snap environment, whereas the command line tool is going to run outside of it, and we don't want two different instances of Open vSwitch to run at the same time, or things are going to not behave. The oven side should be fine because it's accessed over the network, so I'm not concerned about that one. It's really just Open vSwitch that's going to be a problem. So let's see. Basically, we want to see, yeah, that seems wrong. Okay, let's see. What I'm gonna try and do is stop the Open vSwitch that's running, because we don't want that. So I'm just gonna disable actually the old service immediately, and then I'm gonna put some redirections in place to actually access the one running inside of the Snap. I thought I was going to make my life easier by using the Snap for Oven, but this actually might make it that it would have been easier to just install from packages and do the DSSL stuff by hand. Okay. So now I've got systems that do have all the CLI tools installed, but the daemon is not running. If I try to talk to it, it fails, which is fine. That's exactly what we want. Now let's see what the path is for the equivalent thing within the macro oven environment. Run switch. Okay, that looks like what we want. Okay, so actually, can I just do it with a symlink? That would be nicer. Let's see. Well, no, because symlink wouldn't survive reboots anyway. Okay, fine. Let's just do a bind mount. That's gonna be cleaner looking for any command line tool looking at it anyways. Okay. So this, that should make it so that run Open vSwitch becomes identical to what's in the Snap. And let's see, yeah, that's working. So now we're talking to Open vSwitch inside of the Snap environment, and we can see that it's got tunnels configured and all of the oven stuff is in there. Okay, so that should be fine. Now, if we go ahead and treat our network, okay, it's pending again, so let's delete that. There we go. So now it fails because of SSL. So that's what I was expecting to see. And we can see that it's being called here with specific arguments. That's looking for etc oven cert host, etc key host, and oven central cert. I'm hoping we can use the CA instead of the certificate for oven central, but we'll see. So now the next step is to effectively create that stuff. etc oven already exists, so you need to just copy the certs in the right place, make sure it works. At which point we'll have a working environment where we can go back to the Incus code, try to turn those into config keys instead, and just retry things. So let's go ahead and look at those certs again. So they were in here. There we go. So I'm gonna need to copy a few things. So CA cert, we're gonna try and make that this file. Then the next one are the client stuff. So we want client cert. This one is cert host. And lastly, client's priv key becomes key host. Okay. And we can try to see if that stuff works kind of, outside of Incus by just running this and just do show. Okay, so that didn't fail. It shows it's empty, but that didn't fail. So that's a good sign. Now let's try network has been deleted. That's fine. Create it. Okay, that still failed. Why? Failed getting port group UID, my oven setup failed to run. Okay. Formats. No such file or directory. Okay, so it is still trying to access something that's not found. Did I just misname any of the files in there? Sure. Oven central, key host, third host. Okay, so that's seems fine. This is odd. I mean, it's just a find command, so we can just rerun that one. Yeah, so that's not failing here. It does fail when run. Actually, it does show fail to load, start, etc oven central, error SSL. Okay. So it might actually need the certificate, which would be unfortunate, instead of being able to consume the CA. One thing we can do actually is just go look at how it's done within the snap. First, you have the packaging for that open. Yeah, okay. So if we look for micro oven in there, what do they do? Okay, it actually do exactly what I did. Client cert is cert host. Client private key is key host. CA cert.pam is oven central cert. Okay. So that's, oh, hold on. Okay, never mind. I'm stupid. So what happened? All I did is actually perfectly correct. There's nothing wrong in there. The problem is I've got 3 servers and I did it on one of them, so that's the issue. Let me just delete that network again, and well, yeah, okay, fine. It doesn't even let me delete it because some other server is complaining. So I'm just going to be running the same commands on all of them now. That will take care of that. And that's another thing with moving that to the database instead. It means that we don't have to keep things in sync on multiple machines. Like I just have 3 right now, that's fine. But if you had, hundreds of servers within a cluster, you'd have problems. That would get really annoying. I mean, obviously Ansible and the like can deal with that, but it's still annoying. Hey, so delete actually worked fine now. That's good. And do the create again. That should work just fine too. Come on. There we go. All right. And now just to make sure things are fine, let's launch ourselves a few containers attached to that network. The idea is just to make sure that oven itself works properly and we can send traffic between instances across all 3 machines. Okay, so that's the first one created. Let's do a couple more. And Incus is gonna just spread them across all 3 systems, so that will work fine. Okay. All right, so let's see. Yeah, they're all running, they all have IP addresses, that's fine. Let's see if they can talk to each other. They can, so that goes over oven. Do we have network to the outside? We do, sweet. Okay, so that's all working exactly as intended. What we need to get rid of now is that stuff. That needs to turn into config keys instead. So, to do that, let's get to the code. And we're going to be looking for wherever those /etc/oven stuff is defined, which is apparently in here. Yep, there we go. So current logic is that if the database address contains SSL, then we add the arguments. So that's pretty straightforward. Then we spawn the actual command you want to run. Okay. Nice and easy. Now, obviously that's gonna need changing to pull stuff from the database. The config keys, let me just check what we have access to. So just type oven. Okay, we might need to pass a bit more context into that. because this is just being told whether it's southbound or not and what the arguments are to run. It fetches the database address from its own struct, get northbound, and just the struct itself is just a basic OVN struct which has northbound database address, southbound database address. What's missing is any kind of access to the state struct that we carry around within Incus, and that state struct is what has the server config. So that's going to be one thing that needs to be plumbed through pretty quickly, because short of having that, we're going to have issues. Now, let's see how that actually works. So we've got that function called new oven, which conveniently does get the state struct, and it just returns an empty oven and does set northbound, set southbound on it. Not sure why it does that exactly. It's kind of odd. Because like it's literally initializing the struct at that point, so it could just, we could make that a tiny bit faster by just doing nb db adder and directly set that to nb connection here. Yeah. And then same thing with sb db adder and setting that to sb connection instead. And most importantly, we're gonna need to get access to that state thing. So let's just do, usually we do s, so we'll just do s and set that to s. Okay. And now we get to actually do s that we define as state.state. And here we go. Now we've got access to our state directly there. That means we get to actually access the config, which will become quite useful. Anyways, that was just looking at what the code is. As with anything new like that, we're adding new config keys. So let's go and get the API extensions documents open to allocate one for this new feature. Okay. So let's call that oven and SSL config. Yeah, that seems fine. Okay, so new config. Actually, did I put, no, okay, just make that file valid, there we go. And going to the end of that one, same description, so oven SSL config, and just describe what it does. This introduces new server config keys to provide the SSL CA and client key pair to access the oven databases. The new configuration keys are, and that's actually a good question. I don't know what I'm going to call them yet. So if we go back to the doc and look at our server config keys, and they were in MISC, I believe. Okay, so integration bridge is here, and then northbound connection is here. So that's kind of that's the naming scheme we're working with, network.oven.something, okay? And then where else are we looking with that kind of stuff? So this one has an example of C_cert, so that's probably a pattern we should keep. Which means we should probably go with client cert and something like that then. To keep the pattern mostly as it is with other keys. Okay, so that's gonna be our 3 new config keys. Now we need to go and actually add them into the code. So just let me save that file now, and we're gonna be looking for wherever we have. So we're looking for where the existing key is defined. So then that northbound, so oven.north. Northbound, there we go. So we can see it's defined in the migration tool, that doesn't matter. It's defined in the API extensions file, we just edited, that doesn't matter. In the config option file, this one also doesn't matter. It's generated from code, so we can just ignore that one. Network oven setup.md, so that's probably gonna need a change because that's a documentation page. So we probably will want a section on SSL in there. So keep that one around for later. And config.go, so that's the one where I really need to go and update. Configuration.json is also generated from code, so it doesn't matter. And oven.go already have open, that's what we'll actually access afterwards. So that's fine. Now let's go look at config.go. So we can see we've got network oven integration bridge and northbound connection here. Instead of doing like one per key for all 3 of the new keys, since we need all 3 every time, we're just going to make one function that gets us the SSL keys. So it's probably going to be like a network oven SSL function that will then return all 3. So let's get that going. Network oven SSL returns all 3 SSL configuration keys needed for connection. Okay, so the way that works now is we just do config, and I'm gonna go with network oven SSL, and this returns 3 strings. Okay, and network.oven.cassert. Just gonna copy paste that chunk now. Okay, and client cert and client key. Client cert, client key. Okay, so that's that done. Now, next up is gonna be actually using that stuff. I guess at this point we can just make sure that everything still is clean, built, compiled, all that stuff. Let me check what the actual diff looks like. So we're adding the new config key. There's no final new line at the end of the file for the API extensions. That's odd. Why not? It doesn't do end of file new lines by default. Because that's gonna be too much, I think. Oh no, it's actually fine. Okay, cool. So yeah, we'll keep it that way. This file is good. Config, we can see the new function being added there. Then I'll change to the struct to pass in the state, so that's fine. And then the extra extension defined. I might actually go ahead and already commit some of that stuff. So one thing we'll do is, what file is that in? The state stuff is in server network open vSwitch. Okay, so that would be Incus the network open vSwitch pass and add state to oven struct. Okay, so let's just go and include that change in there. There we go. The next one is going to be an API extension commit, so we'll just call it oven SSL config. Okay, and include the 2 commits that do that. Okay, and then we've got, oops. Okay, Incus the, where's the config at exactly? No, it's in cluster config. Okay, cluster config, add oven SSL config keys, and that just includes this one. Cool. So that's just all that stuff committed already. So now we can get to the next step. First off, let's make sure things still build. Yeah, send to the documentation at the end too. Actually, we can generate part of the documentation at this stage. I don't remember what the target is for that. Let me just check. Let me open it here. It's going to be easier to read. So if we open the make file, there is a target in there. We've got a bunch of update targets used to update the generated code type stuff. So there is an update metadata that generates the different files used for the documentation. So we need to actually do that. So run this target. It's going to extract the new config keys. At least it should. I don't remember that. What's what I did? Did it do anything? No. Okay. Let me just look at this stuff again. I thought the server stuff was all defined there, like as commands, but I don't see it. It's later on, isn't it? Yeah, okay. So that's a bit I missed in that file. We need to actually define the config keys in this. That's a map of all of the valid config keys and their validators. So I missed this bit. Let me just go and do that now. Okay. So we're going to be copying this chunk, and that's what actually is used to generate the documentation, amongst other things. So this time the key here is not northbound, it's CA assert. Okay. All right. Default. What do we do when the default is empty? Do we just put it? Apparently we just don't set it. Okay, that's fine. Actually, the default would be content of /etc/oven/ what was the file name again? Yeah, this guy. Because we're gonna want to keep backward compatibility, so I should actually document that we're using those files as a fallback if the config is not set. Oven certificate. Certificate of yeah, that seems fine. And then the config key itself is, I don't know, what did we say? CAssert. Okay, and default value as far as we're concerned from a code point of view is empty. Okay, so that's our new config key for CAssert. Now we need to add the other two. And okay, so CAssert, this one is going to be client cert. So just need to change client cert here. Content of, what was the name? It was host something, host cert. Cert underscore host, okay. That. Oven SSL client certificate. And then copy this chunk again. Just checking something, okay. So this one is going to be client key. So we just go key, oops, and then I just noticed there's a typo in here. Let me go fix that one real quick. There we go. Content of, so this one is key host, if present, open the client key. All right. Let's make sure that our stuff still builds. I'm going to need to go and amend the previous commits to include all that stuff now. And at that point, we should actually be able to generate the new updated list of config keys, because that should get picked up now. So let's look at the diff. So the diff adds that chunk, that's fine. Previous commit is exactly the one we need to amend. So let's just put all that stuff in there. And then do the update metadata commit again. And this time we should get the changes I wanted. And that's something pretty new that was added a few months ago, but it's really neat because it makes it impossible to effectively forget to document something. Okay, so new config options, we can see they are being added to that txt file that's used for the doc, as well as to a JSON file that's used for like web UIs and the like. So that's all good. Let me check what the usual commit message is for that stuff. For those generated files, we tend to have kind of standards. Yeah, so update metadata seems to be one. Did I use something more descriptive in the past? No, just update configs. Okay, fine. So just do, oops, let's do doc update configs. Okay, so that's now included. Next step is to actually do something with that config. So that gets us back to oven.go, and now we've got access to the state. So that's gonna save us a bit of effort there. It's actually kind of funny because we've got access to the state, so I don't know what's the point of this stuff at this point. Like if we just carry the state through to the oven struct, then we don't need to preset that stuff. We can just fetch it as needed, which is potentially better. Or is it because all the commands just access that stuff? Yeah, it looks like they do. Okay. So maybe the right solution, instead of passing through the state like I did, might be to actually fill in the struct with the client key and all that stuff in here instead. That actually seems like a better approach. So let me just close that file. I'm gonna go ahead and drop my previous change. So the add state struct thing I did, I'm just gonna go ahead and drop that. Okay. And now if we look at the file again, there we go, new oven. So what we'll do is actually add new config keys here to hold the CA cert, the client cert and client keys directly within the struct. And then we can actually even store them as properly parsed certificates, but it's a bit awkward if we then need to encode them again every time we want them. So yeah, we'll just keep them as strings. That lets us effectively do all of the processing of like, are they there or not? Do we need to use them or not in the new event function? And then we just use them in the other calls. So let's do that. So CA cert string. Actually, let's prefix everything with SSL. SSL CA cert, SSL client cert, string SSL client key string. Okay. No, I think it's just telling me that not used anywhere. Is that what it's saying? Isn't used. Yeah. Okay. So that's fine. Now here we've got the northbound connection taken from the config, and we can do the check that used to be done later on. So in here we've got that check of, hey, do we do SSL or not? So that chunk, we're gonna just move it. So that goes away from here and that gets moved here. And just do if using SSL, then get the CA and client key pair. Okay. Obviously DB adder here is not set, but that's actually NB connection now. So let's just change that. Okay, and we're not appending any arguments or anything. What we're actually doing is we're gonna try and first check the config keys. So we're just gonna do the old SSL CA cert, SSL client cert, SSL client key, and we're gonna be reading that directly from the database. So global config dot network OpenSSL there. So that's getting those configs through. And what we need to do to kind of support a fallback to the previous way is if they're not set, so if they're empty, then we'll try and read the value from the host files instead. So that's why we need to just go and read the host files. We'll also do better handling, I think, for errors. Like we know that if we're in that SSL path and the user didn't configure the config keys and the files don't exist on disk, it's gonna fail. So we should just fail it with a clean error instead of going through Oven and like getting that massive wall of errors that I got earlier. In any case, let's go ahead and read those files. So the way we do it is we get the content, content and error, and we pass that from, I believe it's IO these days. This stuff has moved, so I'm kind of confused. Like it used to be IO util read file, but I'm pretty sure this has gotten deprecated lately. Let's see. Most of IO util got deprecated in favor of equivalence in IO. So read file, which is the one I want, is deprecated in favor of OS read file. Okay. So we want os.read file. And we're just gonna go ahead with the path directly. So that's oven central cert. Okay. If OS dot is not exists. So we can do like a nicer handling of the case where the thing doesn't exist by doing that. Other cases, we're just going to be returning the error directly. So let's do that. OVN configured to use SSL, but no SSL CA certificate defined. Okay, so let's go with that. So that gets us the value in the variable called content. If everything is clean, we'll just assign that to CA cert. I'm reasonably sure that this, let's see what the definition is, but I'm pretty sure it gets us a bytes array, so we need to cast it to string. Here we go. So that should be fine. I believe it's complaining about OS not being imported. Yeah, and define OS. And yeah, this one should be null. And then the format string. Okay. Let's just go and import OS so that the rest works. Okay. That should work better now. Okay. And rinse and repeat for the other two. Obviously, file paths and everything are different, but yeah, same idea. So that was let's host cert host key. I already don't recall. No, other way around. Cert host cert key. Okay. So oven configured to use SSL, but no SSL client certificate defined. This one is gonna be client key defined. And we need to change here so that it's client cert instead of the CA. So just do client cert. And same deal here. This is going to be client key. And the path is going to be key host instead. Okay. So key host, client not defined, set the config key. Okay. So that's good. Now we've got that stuff all defined here. The points that they're defined right up here and are not really accessible to the struct. So what we could do instead is just move that chunk down a bit. Make it easier. Make it actually possible to alter the struct from it. So northbound, southbound, and we create the final client, and in here we just do that. I still think it's going to be cleaner, well, faster here to do. What was the actual field? So actually the change I had earlier minus the state is something I still want to see. Where is that thing defined? Is it defined after? Yeah. Okay, NB DB other, SB DB other. Okay. So let's do that. NB DB other, yeah, is NB connection, and SB DB other is SB connection. Then we can get rid of those two. Here we go. So that handles the database connection strings. I'm just going to be adding a bit of comments here. Get database connection strings. Let's get southbound, northbound. Create the construct. If using SSL, okay, so that's where we do that stuff now. Is it just saying it's not used? Infrastructure assignment, yeah, okay. So that's obviously makes sense. It's because we need to actually set that stuff. Those are all the functions, and we want SSL CA cert, needs to be SSL CA cert, client.ssl client cert becomes SSL client cert, and client.ssl client, oops, key is SSL client key. There we go. So that should all work fine. We should actually even be able to build this thing. Obviously, nothing actually uses it. So at this point, we just read the config, read those files, put all that stuff in the struct. That's all nice, but it's not actually being passed to Oven in a meaningful way. So that's going to be the next little bit of magic that's going to need to happen here. Is when we actually do use that stuff, so that's in the xbctl command here, we need to go ahead and pass extra arguments. So, well, yeah, pass both extra arguments and extra files also. So let's see how we'll do that. Okay. Handle SSL args, we'll do something like that. Then we need that same check we have earlier for whether to do SSL. So this thing remains. We go back to xbctl here, yeah. Okay. So we again check the connection string, which is going to be a db adder this time around. Okay, db adder. So if we're dealing with an SSL connection, we do need to still pass the actual arguments, but instead of pointing to files, they're going to be pointing to, well, files, but very temporary files. So if we look at the old code here, the arguments are, so it really needs much of the config that I removed earlier. And it's -c to, let's just do proc self fd, and we're going to be using fixed slots, I think. So we're going to do 50, which should be fine. Proc self fd 51 and proc self fd 52, something along those lines. We might actually be able to get the slot numbers beforehand, but I need to figure out how that code works again. So right now, the way this works is we just call subprocess run command, and run command is quite limited. It just runs a command. In this case, we need to pass in files, and we need to create temporary files as loops or something like that we can pass through. To make that work, let's go look at that particular package. I think it's in shared. What's shared? Yeah, shared subprocess and probably in run, maybe. There we go. Run command context, run command inherits. So this one keeps some FDs, runs a command with optional arguments, and passes a set of file descriptors to the newly created process, returning stud out. Okay, so that's potentially what we want. This one, run with commands with run with supplied file descriptors. Okay, so this is also kind of similar. So it's got with FDs. Oh no, this one passes file descriptors for stud instead. That's not what we want. Okay. So yeah, inherit FDs is definitely the one we want. and it passes a list of os.file. The problem with that is I'm not sure we're gonna know the slot numbers. I might want to check how that's been done in other places. Let's see. So if I look at, so in the code base, where are we using this? It's used in LXC in a few places. Okay, yeah, so this command can actually figure it out, so that doesn't really work. That's not exactly what I want. This one's gonna have the similar issue. Yeah, so in all of those, we can't really tell ahead of time what the FD number is gonna be. Oh, actually, can we? PFD numbers higher or equal to 0. Oh yeah, actually we can. Okay, that's fine. So it's really an inheritance instead of putting them in specific FD slots. So we can see how it works here. You get your file descriptor, you pass it through in the list, and the number you just pass as a separate argument through. Let's see if that was done for the others too. Did I just miss that? PDFD is here. Okay, we've got again the same thing with second make PDFD. Okay, anyway, let's see if that works. So general idea is we're gonna need to pass in. So we're gonna need to pass in the specific numbers, which means we need to do something like that. Now, if there were files on disk, we would know the FD number pretty easily. I'm trying to remember what, but I would rather do pipes. I think that would be slightly cleaner. That said, we can do files on disk for the first pass to make sure the concept works, and then we can switch to pipes later on. That seems easier. So this one is gonna be CA cert FD. Let's do something like that. And then for those who are not aware, you can use that proc self FD trick to access a specific file descriptor number as a file. So that's what I'm doing. That way, Oven doesn't need to know any of that stuff. We're just gonna read it like it's a normal file. P is the, oh, actually, this is wrong. This is the client sort FD. P is client key FD. And this one is client, oh, actually, CA cert FD. Okay. So now we've got those files are not defined that will need to be defined. And this one, now we can do run command. It's inherit FDs. And it was called with, it takes a context. Okay, fine. I don't think we've got a useful one, so we'll just do context background. Okay. Then we pass in files and then command and args. Okay. So the files are passed through, command, the arguments, and do we have anything else to pass? No. Okay. So that seems fine. Now we need to actually define the list of files. So this is going to be a, what was the type? OS file. Okay. All right. So that should make it work fine as it stands. Obviously, those are not defined, so that's going to fail. What's it complaining about? Context. Okay. Let's just go import context. Okay. So now context is valid, and we just need those three here. Now, the way I could do that, and that's what we'll do just for a quick test, is we're going to be using temporary files. So we'll do client cert file. What's the syntax for temp files again? There must be something in here. Do we have temp files? No. Just got a blank on that one. Golang temp file. Is it IO that does that? Yeah. It's still IOUTL, but again, IOUTL is mostly duplicated. So what's temp file these days? Not that. I wanted the expansion of this guy. Temp file, OS create temp. Okay, so that's what we need. Fine. And pattern. I think if there is empty, it does the right thing. Pattern. I think both of them are optional actually. Yeah, so there's just, I mean, we can put something in the pattern, but in general, it's not needed. Okay, where am I now? Oven, there. So os dot, what did we say? Create temp, and we'll just do oven. We can just call them oven, that's fine. And that gets us a cert file as well as an error. So if we're getting an error, we need to return said error. Does this thing just return an error? No, string an error. Okay. Did I see that right? String an error? Yeah. Okay. So let's return the error. Then we immediately, so that's a bit of a trick, but we can. Is there a remove function on this thing? No, there isn't. os.remove of client cert file dot name. Yeah. Okay. And we don't care about the return value of this guy. So the idea is we don't want that file to ever be accessible on the file system because it's going to contain confidential details like a client key. So what I'm doing is I'm creating the file, which gets me the file descriptor. I'm not closing that file descriptor, but I'm removing it from disk, which gets me an in-memory file descriptor I can work with. I can pass to other things, but no presence on the actual file system. The other thing we need to do is actually put a defer on the file to close it. So we can do something on that. So handle client certificate. And now we've got this in place. Obviously, there's nothing useful in it yet. So we just need to actually write the content of that file. So client cert file dot write string, and we need to write the actual certificate, which is at SSL client cert, this guy. Okay, so that gives us the first file. This one should probably actually be checked. What's the signature on write string? Because I suspect it might return a length. It doesn't let me know. Okay. Anyway, let's just assume it only returns an error, but I think that's gonna be wrong. Usually write functions return the number of bytes written. So it's complaining now. No new variable. Yeah. Okay. Let's just see what happens. Okay, it didn't complain about that check, it complains about the rest, so that's fine. And this one we should actually be able to do client cert. Is that client cert file dot fd? So we can do that. I'm gonna do the same thing with the other two. Okay. So that's the client cert handled, and now we need to do the keys. So client key file, and the client key, treat everything the same way. instead of cert, just key. And then to wrap things up, we need to actually write the client key. Okay. And then we've got the CA. And the CA certificate. Client, it's CA cert file. CA cert file. More CA cert file stuff here, and here it's also CA cert. There we go. Okay, so all the files exist now and they're being passed as file descriptors. They're all created, immediately deleted, closed on return, and content is returned to them. And we've got the correct content in all three. And this is then being passed through here in the correct, well, like pass through oven. The thing that is still missing is it's not being added to the list of files. So that needs to be done. Otherwise, that stuff's not going to work very well. So the list of files is just called files. Once it's actually properly open, we're going to be doing an append on that. So just going to be appending two files, a reference to client sort file here. And then same deal with the other two. Client key file. Oops. Key file, and lastly this one, CA cert file. Okay, so now that should actually be all passed through correctly. Let's see if that actually builds. Looks like it does. Next step is going to be actually trying this stuff. So in theory, like even the default code path now uses the new logic. So even if it is still using the files on disk, they're now being read into memory, passed through the struct, written into a temp file, and passed to the oven command line. So just transferring that over and then trying to create a network or do anything with oven should exercise that new code. So I'm just going to be transferring the new binaries across. So taking those from data code go bin incus daemon and transfer that to all three of my VMs. So that's oven 01, oven 02, and oven 03. And now if I go look here, just reset those consoles a bit. So I'm gonna go ahead and delete my current daemon binary. Here we go. We'll do that on all three as well. Okay, and then in its place, we're gonna be moving the test binary like that. Obviously, don't do that on any kind of production server. You might have a bad day if your binary doesn't work. And then we're gonna just go ahead and restart Incus. Just waiting for that one to come back. It's taking a bit longer than I expected. Let's go see. Is there any problem going on? Waiting for the cluster members to... Oh, right. Okay. Since we added a new API extension, the cluster must be consistent before it agrees to start up. So you actually need to restart all of them at once, which then unblocks things. And we can see that something is wrong because it's showing an error here saying private key must be configured, can't talk to oven, blah, blah, blah. So it actually shows oven and BCTL being called with procself fd 495051 in this case. No such file or directory, which is kind of odd. Key must be configured to user. Yeah, this is a rather weird one. Let's see. So if I go ahead and create a network under networks, let's create foo. Trying to just get a slightly cleaner version of that error message. Okay. Failed to load client certificate from proc self fd60. Error systemlib. Okay. It does say no such file or directory, which is slightly odd. Not sure about that one. That's an interesting one. I think it's always kind of hard to tell in such scenarios whether the issue is actually related to that file not being found, as in like the proc self fd path just doesn't work, or if it's because of some kind of operations that Oven in this case is trying to do on it that's not working. The other thing that's slightly annoying is with clusters, it's always kind of hard to know what machine is actually running that command. So let me see, because like what I would like to do is actually run incus under strace to see exactly what's being passed to the Oven command, to see if it's a bug in the code or if it's an issue with Oven itself, and we need a different approach. So what I want to do is just stracing the incus process itself. I'm gonna go ahead and delete that network and create it again. Okay. And now let's see. So there should be nbctl in there. Okay. So it did call Oven nbctl in that dump. So if we go look, Oven nbctl exec. Okay. So process 5623 is effectively what we want. You can also see the different file descriptors being passed and close and all that stuff. So 5623. I'm just gonna extract what happened in the Oven command. So we should see this one. Where did it start? It's doing quite a lot more than I expected, actually. Okay, that was the former grep, 5623. I don't actually see the fork, but it's probably right at its beginning. So it's setting up all of the process handlers. And then, okay, so that's just post fork. We can see it's putting the FDs in place. What it does show is as part of putting them in place, it's actually shifting them. So FD52 is placed at position 3, 4, 5, which are the 3 FDs following stud in, stud out, stud out, which are those 3s. So maybe they don't exist because of that. So one easy fix might actually be to just hard code the positions and just say to actually read from 3, 4, 5, given that the rest of the FD list appears to be clear. Anyway, we should see soon enough what happens when it does try to read those files. But right now it's just loading all the libraries and doing all that kind of stuff. It hasn't failed yet at this stage. It's initializing its, so it should be close to SSL because it's initializing its random number generator and loading SSL configs. So it's loading that, and then soon after it should try, yeah, there we go. Proxy FD54, no such file directory. Okay, so it's just because of the slots don't actually line up. So if we just do 3, 4, 5, assuming they're in the same order, which I believe they are, that should actually work. Let's try it out. I'm gonna want to check exactly what we've done with PDFDs in the past to just make sure that I'm not doing anything completely wrong with this approach, but that should be fine. So SSL is the last one, the other ones are added in order. Yeah, that should be okay. So let's try it out. Now, make the binary, transfer it across again, and try to start it. Okay, so pushing to 0, 1, pushing to 0, 3, pushing to 0, 2. There we go. And now let's move them all again. Restart, restart. Okay. And let's see if things are any happier. So we can see actually northbound cluster database server is not clustered. So that means it's actually talking to Oven. Now let's see creating a network. Okay, this one was already created, so that's not a good example. Yep, that worked. Okay, so this is now accessing Oven using those file descriptors passed through proc. So that's all good. Next step is to actually try the config keys themselves, because right now we're still using the on-disk files, so we're just using the fallback behavior. So what I need to do now is doing effectively this, pipe it into config set network.oven.ca cert. Okay, then the host certificate, also the client certificate, and client key. And like this, we can see that all the config keys are being taken just fine. And then go ahead and wipe the Oven on all 3 systems, as they should now be using the new config keys instead. So I'm going to do a quick test. So create a network again, then delete the network, then restart Incus on all 3, and try creating again, just to make sure that it's not some leftover state, but that it's actually using the database properly. Okay, so that's looking good. Restart, restart, restart. Okay, give it a few seconds to cluster and create the network again. And here we go. Okay. Just for kicks, we can go ahead and throw a few instances at that network as well. Just make sure that everything behaves. But the reality is that it's either it's talking to Oven or it's not. Like there's no kind of in between. So this should work just fine. So that's the first instance. Let's do the other 2. Then I'm going to commit the work the way it is. Add the documentation bits, which should mostly be a small section about the TLS, well, the SSL stuff. And then that will be it for this. I'm not going to send the pull request right now because I want to do a tiny bit more research around that FD numbering stuff, just to make sure this approach is safe. Basically, I mean, my concern is that there might be FDs that are inherited all the way through from Incus itself that could then skew the numbering so that the first FD that I'm passing stuff into wouldn't be slot 4, slot 3, but would be slot 5 or 6, at which point the fixed IDs I entered would be all incorrect. So that's my worry there. I want to make sure that the logic will behave in such cases. And we can get an idea for the number of open FDs on Incus itself, which should be quite the list. Yeah, it's got quite a few. The problem is that I can't easily tell which ones would be normally inherited and which ones wouldn't. Normally, you wouldn't want any to be inherited, but that's not always the case. So I just want to make sure that all this stuff is safe. Anyway, let's go into U4 and ping U5. And the other one. Okay, so that's all working perfectly. Now back to the code. Let's look at the current diff. Let's also make sure that all the code is fine. Okay. And this logic is in, what's the name of the file? Open vSwitch, right? So it's incus network. Open vSwitch oven SSL config keys. Okay, so it's effectively that. And that leaves us with the documentation. So let's see what's in there. Currently, it's a bit of a, it's an how-to, so it's quite the tutorial showing all the keys. I don't believe there's anything mentioning SSL. Let's see. Is there? No, there isn't. Okay. Let me look for other files related to Oven in documentation, see if there's somewhere better to put that in. So there's a network Oven reference, but that's not the right thing. Oven peers also not the right thing. Is there an easy way for me to check within docs? Yeah. Okay. Nope, nope, nope. Yeah, so that might be the best location still. Setup. Yeah, I'm not sure it didn't make sense to put it in there. Like, it might make sense to, like, it would need significant changes in there to do SSL also on spawning the daemons and all that stuff. So that doesn't really seem like something that should happen right now. So I think we might be fine with just the documentation entries for the config keys that's been auto-generated and not actually need to touch that file. So that's good, which means we're effectively done. If I just go back in a terminal to look at the commit list here. So that's what we're with. Adding a config key, adding a new API extension, adding the config key, updating the documentation for the new config key, then adding the actual support. This one I'm just gonna reword to add that it says closing the GitHub issue that was filed for this. GitHub issue is 277, so just do that. And that should be it. Testing wise, there's no Oven SSL testing that happens within the test suite, so it doesn't go in there. Instead, it's tested externally with like daily tests where that's gonna get covered. So testing wise, there's no changes needed at this stage. And yeah, that's it. That's that issue covered. I'm gonna do a tiny bit more research to make sure that the file descriptor stuff is all correct. And then I'll send a pull request. So it's gonna add those 3 config keys, and we'll make it easier by not needing to have the config, those certificates files on disk anymore. Again, if any of you want to kind of chime in and try to do some of that stuff yourself, there are a bunch of open issues you can work on. Some of those are actually quite a bit simpler than this. Some of them are also quite a bit bigger, but for example, if someone wanted to look at the 2 certificate related things here, those would be pretty easy to start with. There's David Naguera has taken this forceful product deletion one just a few minutes ago, so that's been nice to see. And there's some bigger ones like adding support for backups of storage buckets, so that kind of thing. But effectively, every time I think of something that could be done a bit better, I tend to just file an easy issue, and then anyone who wants to get started with contributing to Incus can just jump on board and start working on those. All right. Well, I hope this slightly longer than usual, I think, live stream has been interesting. Both showing you kind of how Oven works, some of the internals, and also how to add a new config key to Incus and implement all the ways through in documentation and the actual code and making sure it all works. Again, if you feel like supporting my work, there are a bunch of links just down in the description that can get you to like GitHub sponsors or Patreon or Ko-fi as kind of options. Otherwise, stick around, and we're gonna have Incus 0.4 in probably, I think at this point I'm expecting right after the holidays because we're getting into that time of the year. But there's quite a lot more exciting changes and stuff coming up. So thanks for watching, and I'll catch you in the next one. Bye.